Hi guys, and welcome to the fifth lesson of our coast topic. What we're doing today is we're looking at something called the process of transportation. Now I put those images on there. That's a bit of a trick. In reality, it has nothing to do with humans. This is a physical coastal process, and it links on directly with the work we were doing before the half-term break. So, if you recall, when we were looking at the coastline, I told you there are three processes at work along the coastline. And to make that a bit easier for you, I did this silly diagram with these builders. So we have erosion, transportation, and deposition. And so last half term, we looked at the process of erosion. And I'm using my hammer to wear away this rock. Today, we're going to be looking at the process of transport or transportation, and then in the lessons next week and beyond, we will be looking at the processes of deposition. But just to recap then, guys, erosion is the wearing away of rocks, and that was because of destructive waves. Now, we looked at a few different examples of erosion. We looked at the coastal from the waves, abrasion, attrition, hydraulic action, and solution. And we also looked at erosion from weathering, such as freeze-thaw weathering, chemical weathering, and biological weathering as well. So we've already looked at plenty of different ways in which the coastline is eroded. But the question we've got to have then is, once we've had our erosion on the coastline, where does all that material go and how does it get there? And the answer to that question is transportation. And to give you the key definition here, transportation is the movement of material in the sea and along the coastline. So that material doesn't just disappear, it is moved somewhere else. It is moved in the ocean itself, and it is moved along the coast or along the beach in particular. And so when we have our erosion materials, they are moved along the coast until eventually the final process is deposition. They are let go somewhere else. So the material doesn't just disappear entirely. And so transportation in the ocean occurs in four different ways: traction, suspension, solution, and saltation. So when we have our erosion and that eroded material ends up in the water, it is then moved somewhere else via the water via these four processes. So the first one is traction, and that's where pebbles and larger material are rolled along the seabed. So say we have a large chunk of rock that has come off a cliff, that is then rolled along the seabed via traction and moved to somewhere else. The second thing we have is something called suspension. Now, suspension is very similar to the erosional process of solution in the sense that we're talking about really, really small particles here. And these small particles are suspended in the flow of the water. So if you've ever been to the beach, and if you probably haven't done this, but you could get a cup of seawater. If you were to look in that seawater, it would have lots of really small bits of sand and clay and silt in it. It's not just completely clear. And that's because those small particles are not so heavy that they're going to sink to the bottom of the ocean floor, but they're also not light enough to kind of float on the top. So they're kind of suspended in the middle, and then they follow the flow of the water. So as the waves move in and move out of the beach, these particles move with them. The fourth one is solution. Now this one is where minerals in rocks are dissolved in the seawater. So whereas in the suspension, they're kind of small particles that are just like floating around in the water, in solution, they are completely dissolved, so you can't see them. So if I was to look in the seawater, I can't see all the minerals like chalk and limestone that are dissolved within it. However, if that water then disappeared, if the mineral was deposited or let go onto the beach, it might then start being visible again once it is out of the water. And then finally is saltation, and this is really similar to traction, only this time it's small pieces of shingle or large sand. And again, it bounces along the seabed. So the waves are pushing it, it's bouncing along the seabed, and it's moving that material. And so if we go back to this then, it means that if we have erosion on a cliff and it ends up in the water on the coast, if it's a large bit, it might be traction. If it's a small bit, it might be saltation, and they go down in size accordingly. It's also key to point out here, guys, that once that boulder ends up in the ocean, that is not the end of its erosion. So, for example, if we have a really large piece of rock, as it is being moved by traction, small pieces might be eroded, which then might be moved by saltation. Bits might be dissolved into the water, which is solution, and smaller bits might end up in suspension as well. So once it ends up in that water, the erosion doesn't stop. And so most of these three here are caused by the further erosion of these bigger bits of rock here. That's the premise of it anyway. And so that is how sediment is moved in the ocean. But sediment is also carried by waves along the coastline itself as well. And this process is called longshore drift. Now, longshore drift is a really, it looks quite confusing when you look at it, but when you sit back and think about it, it actually makes quite a lot of sense. And I'm going to show you the diagram here. And this is longshore drift. So, before we kick off and really go to explain it, we need to look at a few different things. Firstly, we've got our words here, swash and backwash. We've already looked at those two key terms. Swash is the movement of the water coming in, and backwash is the movement of the water going back out towards the sea. The direction of the longshore drift is saying that the movement is going from left to right, so it's moving this way. And there's one more word on here that I'm not sure if we've seen before, and that word is the prevailing wind. Now, the prevailing wind is the direction from the wind that is most predominant. So, for example, if the wind is blowing northwest for 75% of the day, that wind would be known as the prevailing wind. So, for longshore drift to happen, we need to have a wind that is blowing in that direction. Now let's go back to our diagram. So there's some key points to know here. What happens is we've got to imagine I have a piece of sediment here. A little blue ball is a piece of sediment. In the direction of the prevailing wind, my sediment is pushed in via the swash onto the beach. It goes back at a right angle because the direction of gravity pulls the wave back out straight. And then the wave comes in and pushes it again in this direction, pulls it back straight. And again, swash, backwash, swash, backwash, swash, backwash. Until eventually, like I said, you can see that in theory, if via longshore drift, my little blue ball of sediment will have moved from this side on the left right the way over to this side here on the right. Again, notice the movement of the swash is via the direction of the prevailing wind. And over time, this is how sediments are moved along the coastline. Now, in real life, this stretch here might be 100 meters. It might be 300 or 400 meters. But overall, it's moving that eroded material along the beach. Now, when we get on to later topics like beach management, we'll see how humans can actually interrupt this process, basically by putting a big wall in the middle of this longshore drift here. But we'll get onto that a bit later on. But just so we can really clear on the entire picture of this whole thing, that in theory, our erosion would be happening somewhere off screen to the left. The material is gathering here, the sediment, via longshore drift. It is moving along the coastline but in the direction of the prevailing wind until eventually it gets here. At some point, this is our final process. This will lose energy and that sediment will settle somewhere else. And that's called deposition. That's our final process we're going to be looking at over the next few weeks. And so I think overall, what I'd like to do here is I'd just like you to spend a minute now, just pause the video and just have a little look at this diagram and make sure you understand what's going on, please. 30 seconds. Okay, so to finish off then, guys, you've heard of Elf on a Shelf. Now get ready for Longshore Drift on a Swift. I'm particularly proud of myself on that one. I'll be honest with you, I had to put it in. I don't apologise whatsoever. But it's up there with the best geography memes going. So say what you will about that one, but I particularly enjoy it. So, some review questions. Firstly, what is coastal transportation? So, for that question, you are giving me the definition and a bit of an understanding about it. Secondly, describe the 4 ways sediments are transported in the ocean. For that question, you are looking at these 4 things here. So to answer that question, you literally just need to go through each of the processes. You can use these definitions on this video as well. And then finally, the question is, explain the process of longshore drift. Please, for this one, guys, I want it in your own words. Don't just copy and paste it off Google, because I'll be able to tell. Use this diagram to really explain to what's happening. Use keywords like swash and backwash, prevailing wind, etc. And then if you can understand this, guys, this is probably one of the hardest things we do on the coast topics. If you get what's going on, you're in really good stead. As always, there is a Zoom link for you to ask for any support, or you can feel free to leave a comment on Satchel 1.